lesson.
Correct.
All right.
They're gonna hear me talk like this.
Like right now, yeah. Start checking
David
your
looks like
homework.
Barack Obama.
I knew it. I knew it.
Welcome back. We're going to be taking
Or you need to shut up. We had gym yesterday, right? We don't have.
Yeah, with no. I have no.
I got 3 periods.
Who's up here? Let's see.
Damien's tight.
Dude, yo. Hey Joe,
Yo.
how'd you do yesterday?
I
Guys,
went twice.
check
won
your
once.
homework.
He ran out of gas in the second.
Joe, zip it. Already for him. Oh,
Oh, sorry.
2. 1 for me, 1 for you. Your homework 5.1 is not going to be due until Friday. Remember, we have a test tomorrow.
Oh dear God.
Okay?
Here's the rest of the front.
Can you go over 5?
On the back.
Yeah.
Yep. Anybody have questions on the front? Tristan,
You go over number 1.
number 1. If the graphs of x squared plus y squared equals 4 and y equals negative 4 are drawn on the same axes, what is the total number of points common to both graphs? Well, think about that. That is a circle with a center at the origin. What's the radius of that circle? 2. And then we have the horizontal line y equals negative 4 is going to be down here, right?
Oh yeah, I got it.
Yeah, so they're not going to intersect anywhere
Okay.
because the lowest value on that circle is going to be 0, negative 2.
Okay.
Okay? On the back here, so Joe, look at number 5 and see if you can work things out. If not, I will go over it. Take a look here. So you substituted in 1 minus x for y.
Yep.
And you should have gotten just negative, or actually positive x squared, because the 1's cancel, and then negative x squared
Oh,
is
you know what I did?
positive x squared.
I didn't take out a GCF. Instead, I divided everything by 2.
But you should have, you had an x squared here.
Yeah,
so
I
you-
know. I didn't.
Yeah,
see
so it would have been a 1/2 x squared if you did that. Any question on number 5 before I move it up? Okay, number 6 was a little bit more work. You should have gotten y equals negative x plus 5 as your linear solved for y here. So substitute that in for y right here. Simplify what's going on in the parentheses and then square it. Expand it. You have to remember how to FOIL here, guys, and then put it back together. Notice that you didn't have to split the middle here. You had a GCF. You divided everything out by 2. Always look for that. You don't really want to split the middle. A lot of you make silly mistakes when you split the middle. Try to avoid that if you can. Always look for a GCF. For those of you that went on, I announced yesterday that the review packet was up, but I also spent a decent amount of time writing out some key pieces of information for you. So under that assignment, if you hit Unit 4 review, I wrote out a bunch of stuff that is, I really feel like you guys should know for the test. Okay? Any other questions on the homework? Jason?
Okay, just look at 4.
Yes, 4? There you go. For the rest of you, loose leaf today. It's on the board. I know some of you are already getting it out. Take out a piece of loose leaf. Jason, are you done?
Yeah.
Okay. And we're starting Unit 5, Exponents. Today is going to be Laws of Exponents. Complete review from Algebra 1. So today's a light day. You have to memorize all of these laws. Know how to apply them. Leave yourself a little space here because we are going to talk about what each component of that 2x cubed is. So, with exponents, obviously you have an exponent, and then there is a base. Sometimes there is also a coefficient. Does anybody know what the base is? Max?
The variable.
It's, in this case it is, but it's not always the variable, so be more specific.
The thing being raised by an exponent.
Exactly. The thing, whether it's a variable or a number, whatever's being raised to a power is the base. Sometimes there's a number that is the base. In this case, the base is x, because x is being raised to the third power. So this is the base. The 3, I hope we all know this, is the exponent. And in this case, anybody think they know what 2 is? Tristan?
Isn't that the coefficient?
Yeah, it's just the coefficient. We're used to that word, right? Okay? Now, if you had something like 2 to the third power, well then 2 becomes your base, because 2 is what's being raised to a power. So just be careful there. The bases can change between variables and numbers. Okay? So we're going to go through all the different laws here. Who remembers this? Anyone? Hands up? No? Yeah. Okay. So the first law, the easiest one, is x to the a times x to the b equals x to the a plus b. What does that mean? Okay. Same base. If they're being multiplied, you add the exponents. Same base being multiplied, add the exponents. That's all you do there. So an example would be, let's see, x to the 4th times x to the 5th times x squared equals what? Well, they're all the same base. The x, okay? So they're all being multiplied. What do I end up with? Max? X to the 11th. Count, just add the exponents up. 5 plus 4 is 9, plus 2 is 11. What if I had something like y cubed times y? What does that equal? Y cubed times y. Maya, right? Y to the 4th. We don't forget that there is a 1 here. This is a y to the 1st power. Okay? So we have to consider that when we're doing anything with the exponents there. What about 8 to the 4th times 8 squared? What does that equal? I don't need it, like, expanded out.
Isn't that 8 to the 6th?
8 to the 6th, which now, okay, this is where you would go to your calculator and you would simplify this. 8 to the 6th is 262,144. 262,144. But it is technically 8 to the 6th. In that case, the 8 was the base. Alright, let's do another one. 5x squared y times 3x to the 4th y. Okay, now we have coefficients here too. Who remembers what you do with the coefficients? Tristan?
Don't you just multiply them?
Yeah, you're just going to multiply the coefficients, and then the base stays the same, and you add the exponents. So 5 times 3, I can start right there, is 15. And now, okay, I have 2 different bases here. I have an x and I have a y. So I have x squared and x to the 4th.
Is it x to the 6th and y to the squared?
And y squared, yeah. So 2 plus 4 is 6, and then y to the 1, let's not forget that, 1 and 1 is 2. Okay, think we're good on that one? Let's move on to the next law. These will only become easier if you do what? What do you think I'm going to say? Practice. Okay? Practice, practice, practice. Division. So I have x to the a divided by x to the b. Does anybody remember what we do here? Joe?
A minus B.
Yes, that equals x to the a minus b. Beautiful, all right. So, for example, here, x to the 10th divided by x squared. So you might see it written two different ways. What does that equal? Max?
X to the 8.
X to the 8. Okay, x to the 10 minus 2, which is x to the 8. What if I had 5a to the 8th divided by 5a to the 4th? What do I do there? Again, we have coefficients here. We're just going to perform whatever operation is going on with the coefficients. Ava, what does that get me?
A to the fourth.
A to the 4th, because 5 divided by 5 is 1, so then that doesn't really matter. I don't have to write it, but if you write it, it's not wrong. A to the 8 minus 4 is a to the 4th. Questions so far? Yes.
If it were, like 5a to the 4th divided by 5a to the 8th, and there's a negative exponent, would you have to move it to the...
Yes, so negative exponents, remember, we don't want negative exponents. So wherever a negative exponent ends up, whether it's in the numerator or the denominator, you move it to the other side of the fraction, and then that exponent becomes positive. Yeah, so that's one of the negative laws.
So
Just
what happens if once you flip it, they're both one of them's a negative again?
It wouldn't be, because you can move one at a time.
Oh.
Like if you had something like x to the negative 4th y squared over, I don't know, z to the 3rd, you would just move the x to the negative 4th.
Oh.
So it would be y squared over x to the 4th z to the 3rd.
Okay.
Yeah, okay? All right. Do a couple more examples of that one. Let's see. How about negative 64 a squared b to the 3rd divided by negative 8 a squared b? Whew, what does that equal? It's the same people. That's the same people. Raise their hand. Damon, what do you got? He's working hard over here.
I'm still writing it down.
Ah, Maya.
8b squared.
8b squared. All of that for 8b squared. Negative 64 divided by negative 8 is positive 8. A squared divided by a squared, well, 2 minus 2 is 0, so that just equals 1. And then b cubed minus b to the 1st is b squared. Yes, we're good? All right. We'll do one more.
Why wouldn't that be 8ab squared?
Because it ends up being a to the 0. What is anything raised to the 0 power?
1.
1. Yeah, a squared divided by a squared is 1. So we don't write that. It's not a, it's just 1. What about negative 10x to the 10th divided by 10x to the 10th? What does that equal? So first, what's negative 10 divided by 10? Josh? Negative 1. And what's x to the 10th divided by x to the 10th? What's any number divided by itself? 1. Yeah, x to the 10th divided by x to the 10th is just 1. So negative 1 times 1 is just simply negative 1. This equals negative 1. Questions? Next. Law. What if you have a power raised to a power? So you have x to the a raised to b. Does anybody remember that? What that law is? Ava?
Do you basically distribute, so you multiply them?
You multiply them, so this becomes, right, this becomes x to the a times b. A power raised to a power, so, or power of a power. Power of a power. Power of a power. Okay? Examples here. X to the fourth raised to the third. Nice easy day for you guys before your test tomorrow. What does this equal? Rory?
X to 12.
X to the 12th. 4 times 3 is 12. What about m squared raised to the 5th? Jamie?
M to the 10.
M to the 10th, good. Okay, let's do a bigger one here. What if I have x squared y to the 3rd all raised to the 4th? So this goes back to what Ava said. This is technically x squared raised to the 4th times y cubed raised to the 4th. You're distributing that exponent to all the terms in the parentheses. If there wasn't parentheses around this whole thing, then I wouldn't be doing it to every piece. So what does this equal? Kate?
X to the 8th, y to the 12th.
X to the 8th, y to the 12th. Questions? Is it all coming back to you now, I hope? What about 4x cubed squared? Now I have a coefficient. What does that equal? Patrick?
16 X to the 6th.
16x to the 6th. Good. You have to distribute it. It's 4 squared, so that's 16, and then x cubed squared, so 3 times 2 is 6.
If it was a big number, like 4x cubed raised to the, I don't know, the 10th, would we have to write out that big number?
Not necessarily. I don't think you're really going to see that.
Okay,
But if you were to write like 4 to the 10th and then the rest of it, it would be equivalent.
okay.
Okay? All right, one more. Negative 2x to the 3rd power. Let's see if somebody can get this one. Jason?
8x cubed.
Close. I agree with the x cubed. Helene? Negative 8x. Because it becomes negative 2 cubed. So it's negative 2 times negative 2, which is positive 4. But then the third one is times negative 2, which would make it negative 8. So just be careful there. Any negative number raised to an odd power is going to be negative. Any negative number raised to an even power is going to be positive. We talked about that. All right. Next law. I know there's a lot. What about x divided by y all raised to the a? Who remembers that one? It's pretty similar to the one we just did, but now we're talking division here. But what do you think happens? Patrick?
X to the power of 8 over y to the power of 8?
Yeah, exactly. So this becomes x to the a over y to the a. So basically you're like, I use air quotes, distributing that exponent to the numerator and the denominator. For example, what if I had 5 over a cubed all raised to the 2nd power? 5 over a cubed raised to the 2nd power. So that becomes, Tristan?
24
25 over a to the 4th. Or to the 6th.
Yes, so this becomes 5 squared over a cubed squared. If I distribute that exponent there, it becomes 25 over a to the 6th. You don't have to show me those in between steps. I'm just doing that for note-taking purposes here. Okay, you can go from there to there. What about 2x over 2x cubed, and this is cubed. All right, what's happening here? Max, what do you think?
8x cubed over 8x to the 9th.
I'm with you on the 8x cubed. Why is it not 8x to the 9th on the bottom?
No parentheses.
Because there's no parentheses around the bottom. Trying to trick you there. Only the numerator is being raised to the 3rd power, not the denominator. Notice the difference here with the parentheses, so just be careful. So the denominator stays the same, but what does that simplify to? 8x cubed divided by 2x cubed. What does that simplify to? Aaliyah? What do you got? I'm with you on the 4. What's x cubed divided by x cubed?
It's just 4.
It's just 4. Yeah, x cubed divided by x cubed is x to the 0, or 1. Anything raised to the 0 power is 1. That just equals 1. Good. I tried to trick you, but I couldn't. All right, one more of these. I have 3x to the 4th y squared, all divided by negative 3x xy squared. Wow. Okay. Take a minute to work on that. See where you get. Expand it out and then simplify it. The parentheses are in the numerator and the denominator, not around both. So you're really kind of dealing with the numerator and the denominator separately. Same basis. Yeah, you add the exponents. So all multiplication. Yep.
This case.
Yes.
This way.
There should be no minus or plus sign there.
Oh.
And then you have to simplify things. That is.
Okay.
All right. What did we get on in the numerator? What's in the numerator here? Max?
3x to the 8th, 3y squared.
3x to the 8th. Did you put another 3 up there? Not another 3.
Is it just y squared?
It's y squared. Yeah, that 3 is out in front, but even if the 3 was in there, you'd only square the 3 one time. Okay? You treat the coefficient, or in this case the 3, as its own separate thing. It's outside the parentheses, so it really doesn't get affected by that exponent at all. But if it was inside, it would be 3 squared times x to the 4th squared times y squared. So just be careful there. And what do we get on the bottom here? Joe?
Negative 3x to the 4th y squared.
Negative 3x to the 4th. Let's see.
Because negative 3x times x is, wouldn't it be negative 3x squared? And then
Ah, careful. Okay, you're you're multiplying these two together first and then squaring it. We don't want to do that. That's in parentheses. So we want to square those two first. So what happens is this becomes negative 3x times x squared y squared. So what does that x become? What is the exponent on the x now?
X to the third.
X to the third, yeah. So this equals, let's see, 3x to the 8th y squared divided by negative 3x to the third y squared. We're still not done. What do we end up with? Equals what?
Negative 1x to the 5th.
Ava, what were you gonna say?
What he said.
What he said? Yeah. So let's see, 3 divided by negative 3 is negative 1. X to the 8th divided by x to the third, 8 minus 3 is 5, so that's x to the 5th. And then y squared divided by y squared is just 1, so we don't write that. Whew. Yeah, Josh.
In the beginning, did you get the 8 from multiplying the exponents?
Yeah, 4 times 2. Yep, because the power raised to a power. And then this technically is a 1, so 1 times 2 is just 2. Okay? All right, let's do a little challenge here. Challenge. Two y to the 5th divided by 6y to the 10th all to the 3rd. Work on that one. Let's see what you come up with. I need a calculator for this one. Those are the coefficients, right? And that's being divided.
Oh.
But now, where should that go?
I know you get y to negative 15 as an exponent, I just don't know where to put it.
Well, where is it, where are you gonna, so you would put it on the top,
Okay.
but then you have to move it. Alright, so some of you, alright, this one was tough, huh? Let's work it out. Let's work, it comes out to be something quite simple. So let's see. What do we get on the top? Well, we get 2 to the 3rd, right? Which is, Ava? 8. And then y to the 5th times, to the 3rd is y to the 15th. And then on the bottom, we get 6 to the 3rd. Ava?
216.
216. I'm asking her because she got the right answer. And then y to the 30th. Okay. All right. So now, 8 divided by 216. I don't want to get a decimal here. If you have a fraction like this where the numerator is larger than the denominator, just simplify it. What does that simplify to? 8 over 216.
127.
Yeah, 1 over 27. That's what that simplifies to. And now I have y to the 15th divided by y to the 30th. So what is that? Where do I end up?
Y to the negative 15.
So that ends up here, right? Y to the negative 15th. Sorry, that's not y minus 15. It's y to the negative 15th. But we can't have negative exponents. We talked about this earlier. So this becomes 1 over 27y to the 15th. Okay, wherever you have the negative exponent, it's in the numerator, I move it to the denominator, it becomes positive. That's not magic, it's mathematically correct. But for your purposes, just know that you move it and it negates it. Okay? Alright, so we have 10 minutes, which is amazing. Any questions about today's lesson? I'm going to start there. About your laws of exponents for today. No. Okay. Questions about past homework, or, because I didn't go over the homework yesterday, so I will look over that, or anything about the test. Arden.
I was absent for the circle thing, so I don't fully understand.
Okay. You were absent for the first day, right? The linear. Okay.
How to, with the equation.
Yeah. All right. I'm trying to think. You're gonna have to come to me
Okay.
tomorrow morning,
Okay.
early. Yeah. Okay. Tristan?
How many questions are on the test?
Oh my god. I hate that question. I have no idea. It's worth 42 points. I think there's 16 questions maybe? Yeah. So I trimmed it up a little bit, but that means there's less points, right? So every point you get wrong or you lose is more percentage points. Just keep that in mind. Any other questions about the content of the test? Not how many questions or anything like that? Josh,
Question over here,
what is that?
but, like, it was
On that?
somewhere, but I was
Alright.
confused.
Alright, so right now for the next 10 minutes, work on your homework. You can study, look at your notes, think about questions that you want to ask me. I will come around.
I don't know, very messed up. When I was doing it. They got to that and I was doing it.
Did you, alright, so here?
No, it was like, I'm pretty sure it changed around like here. It was 2 minutes.
Okay, hold on, let me look. Okay, so that should be minus 4x.
Where did that come from?
Because it's going to be
Negative.
negative, no. Yeah, and then it's going to be 2 times negative x, so it's going to be negative 2x plus negative 2x, which is going to get you negative 4x, so you FOIL that wrong. That should be negative 4x plus 4, everything else is right. So that's just going to make that a 6x instead. No, a 2x, right? Yeah, there you go, yep. Yep. That's my, you know. Where's the lesson?
The roots of a parabola are just the x-intercepts, right?
Yes.
Okay.
Solutions, roots, zeros, all the same thing.
Okay.
Okay, so you missed circles though, right? This?
No, I was,
The original circles.
yeah.